Picture this. A fully loaded passenger jet weighing close to 400,000 pounds drops out of the sky and hits the runway at around 170 miles per hour. All of that weight, all of that speed, slamming down onto a handful of rubber tires in a fraction of a second. By every instinct you have, those tires should burst. Your car tire would shred instantly under a tiny fraction of that abuse. So how do airplane tires survive landing after landing, sometimes hundreds of them, without exploding? The answer is one of the most impressive pieces of engineering you've never thought about, and it comes down to a counterintuitive trick. These tires don't survive despite being under insane pressure. They survive because of it. Stick around, because by the end you'll understand exactly why, and there's a clever safety feature hidden inside them that almost nobody knows about. Let's start with just how brutal a landing really is for those tires. A large jet like a Boeing 747 lands on around 18 tires. That sounds like a lot, but consider the load. Each one of those tires can be carrying tens of thousands of pounds at the moment of touchdown. And it's not a gentle roll-on. It's an impact, the full weight of the aircraft transferring onto cold rubber in an instant. On top of that, there's the speed. The plane is moving forward at around 170 miles per hour, but the tires are completely stationary in the air. So at the exact moment they touch the runway, they have to go from zero to spinning at full speed instantly. That violent jolt is why you sometimes see a puff of smoke at touchdown. That's the tire being dragged up to speed against the runway in a split second. So we've got crushing weight, high-speed impact, and a brutal jolt all at once. By any normal logic, the rubber should give out. But it doesn't. And the first reason is the very thing you'd assume would make it worse. Here's the counterintuitive part. Your car tire runs at about 30 to 35 pounds per square inch of pressure. You'd think an aircraft tire, to be safe, would be softer, more cushioned. It's the opposite. An airplane tire is pumped up to around 200 pounds per square inch. That's roughly 6 times the pressure in your car tire. Why so much? Because that extreme pressure is exactly what makes the tire strong. When you pump a tire up that hard, the air inside becomes incredibly rigid and supportive. It's almost solid in how it pushes back. That rock-hard cushion of compressed air is what lets the tire carry such enormous weight without flattening, deforming, or tearing apart on impact. The pressure isn't the danger, the pressure is the defense. A softer tire would fold and fail. The overinflated one holds its shape against the full weight of the jet. And there's a second clever detail. Aircraft tires usually aren't filled with regular air. They're filled with nitrogen. But regular air contains oxygen and moisture, and under the extreme heat and pressure of landing, that's a problem. Oxygen can react and moisture can expand unpredictably. Nitrogen is inert and dry. It doesn't react, it doesn't feed a fire, and it handles big temperature swings far more predictably. So the tire stays stable even as it heats up violently against the runway. The pressure is only half the story. The tire itself is built nothing like the one on your car. Inside an aircraft tire are layers upon layers of incredibly strong fabric cords, often made of materials like nylon and aramid, the same family of fibers used in bulletproof vests. These layers, called plies, are wrapped around the tire to give it tremendous strength. A car tire might have a couple of these layers. An aircraft tire can have many more, all bonded together into a structure that can withstand forces that would obliterate an ordinary tire. This is also why aircraft tires are tested far beyond anything they'll ever experience in normal use. Manufacturers don't just check that a tire works at landing speed. They burst test them, spinning them faster and loading them heavier than any real landing, all the way until they finally fail, just to confirm there's a massive safety margin. A tire rated for 170 miles per hour might be proven safe at speeds well beyond that. So in everyday service, the tire is operating comfortably within its limits, never anywhere near the breaking point. The landing that feels so violent to you is, to the tire, a routine day at well below its true capability. Now here's the feature almost nobody knows about, and it's brilliant. All that braking, all that friction with the runway, generates enormous heat. Aircraft brakes and tires can get extremely hot, especially during a hard or aborted landing. And heat is dangerous for a tire, because as the gas inside heats up, its pressure rises. In theory, enough heat could push a tire toward bursting, and a tire bursting explosively could send shrapnel flying. So engineers built in an elegant solution called a fuse plug or thermal plug. It's a small plug set into the wheel that's designed to melt at a specific high temperature. If the wheel ever gets dangerously hot, the plug melts and deliberately releases the nitrogen in a slow, controlled way. The tire goes flat safely instead of exploding violently. It's a sacrifice the tire to protect everyone design. Far better to have a deflated tire than a tire bursting like a bomb on the tarmac. It's the kind of quiet, clever safeguard that defines aviation engineering. Anticipate the worst, and build in a controlled way for it to fail safely. So what's the takeaway the next time you feel that thump of touchdown? First, that landing that feels so jarring to you is, to the aircraft, an everyday event the tires are massively over-engineered to handle. The bump you feel is well within limits that were tested to extremes long before that plane ever carried a passenger. Second, this is a perfect example of a theme that runs through all of aviation. Nothing is left to chance, and many safety systems are designed not just to work, but to fail safely when pushed too far. The fuse plug is the proof. Engineers didn't just make the tire strong, they planned for the rare case where even that isn't enough. And here's the bigger picture. We tend to think of a tire as a simple, dumb piece of rubber. But an aircraft tire is a precisely engineered pressure vessel built from bulletproof-grade fibers, filled with inert gas, tested to destruction, and fitted with its own safety release. All so that 400,000 pounds can drop out of the sky and roll to a gentle stop hundreds of times on a few patches of rubber. The next time you hear that touchdown thump, you'll know just how much engineering is holding you up. It's incredible how something we completely take for granted, a tire, is actually one of the most overbuilt, ingenious pieces of engineering on the entire aircraft. If you enjoyed this, do me a quick favor and tap that like button. It genuinely helps more curious people discover these videos. And if you want to keep uncovering the hidden engineering behind the things you experience every day, make sure you subscribe and turn on notifications. Here's my question for you. What's something about flying you've always wondered about but never had explained? Drop it in the comments. It could be my next video. Thanks for watching, and I'll see you in the next one.